Alright, here we are. Today we are going to learn about the Earth's layers, and this is a sheet that you can also print out and download. Shh, guys, sorry about that. Print out and download. What we're going to do first is we're just going to start by coloring and labeling certain things. As you can see, this is like if you could cut into the earth and get out a pie piece, this would be your pie piece. We have, first of all, very important layer is called the crust, and I'm going to shade this in brown. The crust is what is underneath the ocean and is also underneath all of the land on the surface of the earth. So we have crust here and crust here, and on the side view that of course is also crust. I'm going to shade that in as well. Okay, and we're going to label it. Because part of it's under the ocean, we usually refer to that as oceanic crust. So you can either cut out the side tabs and glue them on. That's an option. This pen is not working very good. Oceanic crust. And crust underneath the continents would be referred to as continental crust. And then we're just going to shade in the land portion here, the continent. We're just going to choose green and shade that in. And for the ocean, we'll shade it blue. This is not an art project, guys. This is just to get an idea of the internal parts of the earth so we can understand why things happen on our planet, such as earthquakes, and how landforms build and so on. Alright, so beneath the crust, and you could, if you want to, label this continent, label this ocean, but we're going to continue on. Normally this would be cut out, but we're not going to cut anything out. This is the next layer that's directly beneath the continental and oceanic crust, or beneath the crust. And this is just more crust, basically. That's all that is. Actually, I take that back. This is actually the upper mantle. So if you're using your cutouts here, find upper mantle. This is the upper mantle. I'm just going to try and label it with this pen that don't work. Upper mantle. And important to understand is that the crust and the upper mantle combine, and that's why you see this little bracket here, because these two combine, these two layers, to make what's known as the lithosphere. And if you remember from our initial discussion, the lithosphere is just the rock layer, the solid rock layer of the Earth's interior. So the crust and the upper mantle make up the lithosphere, which is, lithos means rock, it's the rock layer. So it's the crust and the upper mantle. Okay. Alright, directly beneath the lithosphere, or the upper mantle, is the mid-mantle. In the mid-mantle, we have convection currents, and I believe we touched on that before we split for spring break. And this layer we're going to color in orange. It's a layer of what I like to refer to as ooey gooey molten magma. So if you ever seen a volcano, what comes out of there is lava, because once magma hits the surface, we refer to it as lava. But this is where that stuff is coming from, believe it or not, all the way down here. In this ooey gooey layer of molten magma is referred to as the Asthenosphere. Asthenosphere. It's ooey gooey. Molten magma. And within this molten magma, we have those convection currents where, remember, convection currents is where hot materials rise because they become less dense and cooler materials sink because they're more dense. So where would the hottest place be in this layer? It would be towards the bottom, because all of the heat still comes from the interior of the earth when the earth was formed. So the warmest part would be here, and this stuff is going to rise as this ooey gooey molten magma rises towards the upper portion of this mid-mantle or the asthenosphere. It cools because it's cooler here, hotter here. So it starts to cool and then it sinks again because cool materials are more dense. So your convection currents should look like mine. Once again, warmer towards the center of the earth because the center of the earth contains all the heat of the earth from when it formed. So that warm magma down here is rising and it reaches that upper mantle or the lithosphere, and it's cooler here, so it begins to sink again because cool things are more dense. Alright, so these are our convection currents in the asthenosphere. I'm going to write it. You can cut it out if you wish, or just follow my lead. I can write with this thing. Convection. Wow. Currents. And this is in the asthenosphere, aka the mid-mantle, because this was the upper mantle, the middle of the mantle, and now we're going to get to the lower mantle here. And of course it's going to get hotter, progressively hotter, as we move towards Earth's interior. So we're going to make this red, the lower mantle. And label it. And then we get to an area known as the outer core, which is this. I'm going to shade this in red too. If I have a darker red, it would be nicer. I think I do. Let's try this one, because it's getting progressively hotter and hotter as we move towards the inside. It doesn't really matter what color red, it's not important, but as long as we know that we're getting progressively hotter towards the inside, the heat is coming from Earth's interior. And I'm just going to do the inner core yellow. Now let's label them. So we had the crust, upper mantle, crust and upper mantle combined to make the lithosphere. Mid-mantle is where we have that ooey gooey magma. That's where it resides, and it's moving, it's in motion because of the heat towards the bottom of the mantle and the cooler regions towards the upper mantle. So we have convection, the magma is moving in circular movements. Then we have the lower mantle. Then we have the outer core and the inner core. Okay, so this is the hottest area. And we can actually fill in some of this information here. like. So the mantle is mainly made up of silicone, and I'm going to abbreviate with the symbols. So we're looking at the elements that are in the mantle: oxygen, iron, Fe for iron, and nickel. Its thickness is about 2,900 kilometers, and it is solid. So the crust, people often ask, well, how far have we drilled into the Earth's interior? Well, we haven't ever drilled past the crust. We have no ability to do that. Then we have the mantle, which pretty much is composed of the same thing: silicone, oxygen, iron, and nickel. I think I messed up here on the thickness, but that's okay. I'm going to say 2,900 kilometers thick. The crust is not that thick. That's incorrect. I think the crust is only about, depending on where you are, the thickness ranges to about 32 kilometers, and that would be, sorry, I messed y'all up, 32 kilometers, and that would be where you have mountains. So where you have no mountains, it's not going to be as thick. This too, mantle is also solid. What's interesting here is when we get to our outer core, it is basically iron and nickel. Its thickness is about 2,250 kilometers in thickness. And the state of matter here, as we already said, oh no, we haven't said that yet, is liquid. The outer core is liquid, and the outer core is in motion similar to the mid-mantle. And due to this motion, it creates Earth's magnetic field. So motion, because it's made up of iron and nickel mainly, so it causes Earth's magnetic field. So around the Earth, the magnetic field that shields us from a lot of different things from the sun is down here. That's the reason. And then the inner core, it's the hottest layer. It too is composed of iron and nickel. It has a thickness of approximately 1,300 kilometers. And the state of matter is now solid again, even though you think these are the same composition. Why is this solid here instead of liquid? It's solid because of all the pressure of all these other layers right on top of it, so it's condensed into a solid. Alright, for our purposes, learning about geology, learning about Earth, the study of Earth, our most important layers are going to be our asthenosphere, or the mid-mantle with the ooey gooey molten magma, and the upper mantle, along with the continental crust that creates the lithosphere. So let's start lithosphere and asthenosphere, because they're going to be the ones we're going to be talking about most, because they are the reason that we have what's known as plate tectonics, which we'll be getting into. So this is how you would create this foldable, even though we haven't cut it out. But like I said, you sure can apply the labels here and then add in addition to if we've added something that is not there. But just know that these are the layers, the lithosphere and the asthenosphere, that we will focus on from here on out. Thanks for watching.